So welcome back. Today we'll continue talking about spatial filtering and we stopped last time on the example with the convolution, simple convolution and correlation. Now let's take another example. Consider this kernel. We are going to apply this kernel into this input image, okay? And to apply this kernel into input image, we will going to center this center point first on this pixel over here. If you want to rotate it by 180 degrees, so these will go up here, okay, and these will go down here. This is the first step, will go down, then whatever is here will go here, and whatever is here will go here. So you will end up with a filter which is revolved or rotated by 180 degrees. You can look at it in another way. You just put a diagonal line over here and you flip the bits by the diagonal line. So this one will come here, this one will go back in its place, this one will go here, this one will go here, the one will stay the same. You end up with the rotated filter. Now this is your input image. So first of all, we are going to apply the 2 over the 2. Okay, so and you can see that the overlapping is with the 2 and the 1. So we multiply 2 by 2 is 4, 1 by 2 is 2. So we have 4 plus 2 minus 2 plus 1. Okay, so this is your values. Okay, so this is 4 plus 1, which is equal to 5. So the first pixel will equal to 5. Then we keep on moving. We apply the 4. Of course, we did not do zero padding like we did earlier. Zero padding is just to show you that you pad the outside bits with zeros. And as you know, zeros will have no effect on your values because anything multiplied by 0 is basically a 0. So the next step is to apply our filter over here. Okay, we apply our filter. So the 4, we will have to multiply these. The minus 1 by 2 is minus 2, 2 by 2 is 4, plus 2 by 2 is 4, plus minus 2 plus minus 1 plus 3. So minus 2 with the minus 2 with the 4 will go. The 4 minus 1 is 3, and 3 plus 3 will equal to 6. Over here we got a 4. Let me double check. So minus 1 multiplied by 2 is minus 2. Then 2 multiplied by 2 is 4. Then 1 multiplied by 2 is 1 multiplied by 2 is 2. Then minus 2 multiplied minus 1 multiplied by 2 is minus 2. Then minus 1, then plus 3. So this one was wrong. So we will have minus 2 with 2 will go, minus 2 with minus 2 with minus 1 with 3 will go. We will end up with a 4 over here. So we keep continuing the same way. We will move the filter across, and at the end, we are going to get our final result looking like this. So this is our image after applying this mask to this image. So it will take some time, but at the end you will have to find the final image. So why is these operations important? So the first operation that we are going to talk about is smoothing spatial filters, or what we call them low pass filters. When we talk about low pass filters, if you remember in the frequency domain, okay, in the frequency domain, if this was the frequency, this was the output. So the low pass filters will have something like this. So the low frequency will pass, this is low frequency, the high frequency will be removed. So in other words, whatever value having low values, it will pass, otherwise it will the high frequency will be suppressed. So this is called a smoothing filters, which are used for blurring and noise reduction. So blurring is used for pre-processing steps such as removing small details from the images prior the object extraction or the feature extraction. Noise reduction can be accomplished by blurring an image. We have the type of smoothing filtering. There are two ways for smoothing filtering, either the linear filtering or the order statistic filters. So the smoothing filters, they are linear spatial filters and is simply the average of the pixels contained within the neighborhood of the mask. So we apply the average of the pixels. This is also called averaging filters. The idea is replacing the values of every pixel in an image by the average of the gray levels of the neighborhood of the mask. So this is an example. So you can see this is a standard averaging filter. What we do is 1 plus 1 plus 1 plus 1 will give you 9. 9 multiplied by 1 over 9, you will end up the same. But what we have done, we averaged the pixels. We averaged the pixels, okay? All the pixels, all the 9 pixels, the original pixel and its neighbors are all combined together, and everything is averaged. So we get this. This is called the standard averaging. This is called the weighted averaging filter, and you can see it's weighted. The center will have 4. This means the center pixel has more weightage compared to the other pixels. The N4D, okay, N4D will have higher weightage, which is 2, 2, 2, and the N4 pixels will have higher weightage. The ND pixels will have lower pixels over here, or lower values over here. So smoothing filters is basically implementation of the filtering by M by N image with a weighted average of the sum of the given images M by N. So basically this is the same function as earlier, multiplied by the sum of M and N. Okay, multiplied by the sum of M and N, which is our filter. So over here we sum 1 plus 1 plus 1 plus 1 will give you 9. Over here we sum 1 plus 2 plus 1 plus 2 plus 4 plus 2 plus 1 plus 2 plus 1 will give you 16. So we sum the filter, and here is the original applying of the filter mask to the image. This is an example. This is you can see this is the original image. If we apply a 3 by 3 mask, it starts to blur. Over here a 5 by 5 mask, and over here it is a 7 by 7 mask, and you can see that the image is blurring as we go on. The order statistic filters. Order statistic filters are nonlinear spatial filters whose response is based on ordering ranking of the pixels contained in the image area encompassed by the filter, and then replacing the values of the center pixel with the value determined by the ranking result. Okay, by the ranking result. So it is best known as the median filter. So we apply the filter for all the pixels, and then we get the best ranking result of all the pixels, neighbor pixels, and we apply it to the center pixel. So for example, the cropped region neighborhood, sort the values of the pixels in the region, then find the M by N divided by 2, 2 plus 1. So over here we have these pixels as we got them as our result from the filtering. Next we sort them out. Sort them yani we put them in ascending order. So 5, 10, 15, 20, 20, 20, 20, 20, 25, 100. ترتيب تصاعدي. Okay, then we want our fifth pixel, because this is our pixel. So we have, this is 1, 2, 3, 4. This is the fifth pixel. So this value will be put in the answer. Okay, this value will be put in our answer. This is called median filter. This is called a median filter because we choose the we sort the values and we choose the value of the median or the middle filter, middle pixel of the sorting. Now averaging, compare this to averaging. averaging, um, let's say I had the pixels with the values of 10, 15, 20, then 20, then 20, then 70, then 90, then 100. Okay, so over here these I will have this is our fifth, so I will need another one, so 200. Okay, let's say this is a 200. Now this in this case, if you look at it, you see it's not that important, but what actually is, this is an image. Okay, this is an image where part of your neighbors are very bright and part are very dark. If you do averaging, you are going to do plus the dark plus all the pixels, divide them by their values. You will end up with a pixel which is considered brighter than the actual value. In a median filter, what we do is we choose based on the location. We do ascending. If all of them were bright, this pixel will be bright. If all of them were dark, this one will be dark. If the pixels are divided in the middle, we will get something which is not dark, not very dark, and not very light. So something in the middle will do it. So this is the median filter. This is the result of applying a median filter for an image using noise removal. You can see all the noise over here are removed from the camera pixels. Okay, so this is the end of our week number 5. So see you soon, and please stay safe.